Adding, subtracting of algebra. So before we start simplifying algebra, we'll have to go over our integer rules. When we look at our integer rules from last year, we had to summarize it simply as just saying when they're both positive numbers or they're both negative numbers, you add them up. Add, and you keep the sign. I'm going to explain this more when we get down on the middle of the page here. If they're different, you subtract and you keep the biggest sign. And I will also explain that. But I just want to make sure that you're very aware that these, and I gave you a little blue sheet in class to memorize these rules. It's 2 simple steps. If they're the same, add them up. If they're different, you're going to subtract them. So we're going to start back from what you did last year. A lot of the stuff that you saw last year had the brackets, the plus here, another plus in front. You also had subtracting, like these ones down here. So I'm just going to go over what you would have seen last year and what it's going to look like this year before we attempt the actual algebra. So last year, I could just go back and erase that so you can see it better, is you would have seen the brackets. And this is really just something that says like 2 plus 5. If I remember, 2 is just a 2, positive 2. I'm adding something else. I really don't need the plus in front of the 5 because say it's positive. I really don't need those brackets. It's really just 2 plus 5 is equal to a positive 7 is equal to 7. Also, this is where it becomes complicated. That's why they put it in brackets to protect it, is I'm adding 2 negatives, a -4 and a -2. If I look back at my rules, if they're both negative, here, you see them here? Not that I'm covering it, but one is a negative, another negative. You add them up, but you just keep the same sign. So it's the same thing. -4, so 4 plus 2 is 6, and they're both negative, so you keep it negative. It's as simple as that. Now, last year you would have seen sometimes something that had a subtraction. Last year it would have said, keep the first one, change the middle to the opposite function operation, so minus to plus, and then you also change the last one here. So hopefully remember that. So that actually just turns into a positive 2 and a positive 7. Add up all your positives, positive 9 as a final answer. Same thing goes here. I'm going to change, -3 doesn't change. The negative becomes a plus, so minus becomes adding, and this changes to a -2. So again, I'm adding here a negative, so you keep it negative, add it up, -5. I do want to try to skip to one that will give you different signs. Okay, the next one does. So again, if I change this to, I can't subtract here the integers, so -2, don't change. My minus becomes adding, and this one changes to a positive 7. Now for the first time, my signs here, I have a negative and I have a positive. Different rules. Look back at the top of the page. When they're different here, you subtract and you keep the biggest sign. So let me explain that. That means you're taking 2 out of the 7. So 7 take away 2, I'm left with 5. Which number is bigger? Don't look at the signs, okay? Just look at the number. The signs are important, but when you look at the bigger number, just the number, the 7 is bigger. So it controls the biggest sign, what's left over. You're basically taking 2 of these out of here. So you're left with 5 positives. One more little practice. Here again, if you have a -3, don't touch it. Minus became adding here. This became the opposite. Oh, easy. I have a -3 and I have a +3. You're subtracting. Well, 3 minus 3 is 0. Last one here for just integer practice, and then I'm going to introduce it to what we see in the algebra. -6, don't change. Change that to adding, and change your last number there to a +2. So you're adding this time, right? You're adding, but they're different. Negative and positive means you're subtracting. So take 2 out of this. You're left with 4 negatives. The only difference that we see this year, when we look at, it's the same rules of your integers. You're going to get lots of practice with that, okay? This year in secondary 2, we never have double signs. So let's say your sentence looks like this. Well, you're not going to have all these brackets, so it's just -2. If you have 2 positives like this, or even if, I can go back a little bit, if that positive was inside the bracket, so -2, I don't like the 2 positives like this. I don't want double signs anymore. If they're the same, just to get rid of your double signs, it stays positive. So then I have simply 2, take away 2. I have an answer of 0. If they are the same, if I have this happening, -2 stays. The double signs, no double signs, and you're going to see that why. So get rid of it. If they're the same, to get rid of double signs, it goes +5. So now I have a question like, we're in green here. They're different, so subtract. Take 2 out of the 5. I'm left with I'm left with 3, not 5. Take 2 out of 5. I'm left with 3. 5 is bigger, so it controls it. Your answer is a +3. So you're going to have these numbers lined up like this. They're no longer going to have double signs or brackets everywhere, because it leads really into your algebra skills. Okay, let's get into the algebra part. Don't forget these skills up top. That's not going to change, okay? They're integrated right inside of the algebra. Now, if I read my instructions, in algebra, you can only add or subtract like terms. We know what like terms are. Those are my twins, my perfect twins. Same variable, same exponent. Then it says, find the difference, add or subtract the coefficients, which is the number in front. So we're going to keep it super simple. If I talk about this being 2 A's, that's a 1A, that's a 1A. I don't need the ones there. It's an A and an A. Here I have 3 of them. They're all positive, so I'm adding them all up. I have 5 A's. Think I have 2 apples here, 3 apples here. How many total apples? 5A. The next one, you can only combine like terms, my twins. This one doesn't have a twin. We'll worry about B after. We'll do everything in alphabetical order. I have a -3 and I have a -A, which is really a -1A. So really you're doing, I have -3 and -1. Look at it this way, -3 and -1. I want to put these together. I want to squish them together. If I owe you $3 and I owe you another $1, that means I'm now owing you -4. I'm in debt $4. And they are, what kind of 4s are they? They're A's, so -4A. Same rules. They're both negatives. Add them up. Keep a negative sign, just like your integer rules. Now B has nothing else, so you just rewrite it in alphabetical order. This is your final answer, right there. -4A plus B. Next question. 1 and 1. How many n's do I have? 2n. Next one. Oh, my x goes first. There's no twins, so I don't have to worry about it. Here, I have my 2 y's. I'm always circling what's in front of the variable. So I have a -3 and I have a +1. They're different. Take 1 out of the 3. So you're left with 2 negative y's. I can rewrite this by explaining it to you like this. I have a +1 and I have 3 negatives. These two collide. They cancel each other. +1, -1. Subtract. They're gone. That's why you're left with 2 negatives. This is your final answer right here. It's in alphabetical order, nice and clean. Doesn't do anything else. That's your final answer for this chapter. Next one, really it's just 3 minus 1. If I take away the algebra, guys, it's just this, 3 minus 1, which is 2, but what kind of 2? 2 A's. Again here, I have my A's that go together. Take 1 out of the 5, I'm left with 4 negative A's, and just rewrite the B over here. Then I have my next one. I have a negative 6 minus 6 and a minus 2. I interchanged minus and negative. It means the same thing. Okay, so this is a minus 2 and a minus 6. My integer rule means, so if I just totally ignore the algebra for right now, totally ignore the algebra, it's just minus 6 and minus 2. So if I have 1, 2, 3, 4, 5, 6 negatives, and I have 2 negatives, how many total negatives do I have? I have negative 8. But be careful, we are doing algebra, so what kind of negatives are they? They're negative 8c altogether. Next one here, I have 2n and negative 4. So take the 2 out of the 4, you're left with 2 negatives. N plus 4 plus 3, back to kindergarten. I have a little plus 7 at the end. These are, I know it's weird, okay, but these are your final answers. You cannot go any further that I've just highlighted in green. They are your final answers. Okay, next page. I usually teach this in 2 steps. So if you need to go into your notes and practice a little bit of this, I would strongly suggest that, is grab the first practice page before you move on, because it is overwhelming to do both all in one shot. Okay, then we talk a little bit about the brackets. So there was no brackets. Now there's brackets. I'm going to simplify this a little bit. I'm going to do this to it. Oops. I'm going to cross it out instead of doing that. I'm going to cross it out. I'm going to make it a little bit simpler, okay? Let's just focus on this with just brackets. Then we're just going to focus on this one here. Okay, make it a little bit easier. A negative sign outside the bracket changes the signs inside the bracket to their opposite when we remove the brackets. All that means is that when there is something, right now we only have to look in front, right here. If there's nothing in front, just take the brackets off. Done. And you can't go any further. Okay? That's all you have to worry about right now. If there's a negative in front, like this one, read the instructions. All it just said there was you change everything inside to its opposite. So if that's a 6, that's really a plus 6. It changes to a minus 6. F. And the second one also, if it's a minus 3, it gets changed to a positive 3. You're changing everything inside to its opposite sign. Remove the brackets. Done. Those are both your final answers. They don't go anywhere. Simplifying, you're making it as small as possible. Next questions, which are a little bit more challenging. This one here has a bunch. Remember, like terms are when they are exact twins. So the exact twin of this guy is only this one. So in this question, I'm doing minus 4 and positive 6. It's really just like saying 6 minus 4, you're left with positive 2. So take your 4 out of the 6. You're left with 2x cubed. Always start with the stronger exponent. The next one, you have squares. Remember, highlight what's in front. Plus and a plus. Oh, that makes it super easy. You're just adding everything up. So that just means 5 plus 7, 12x squares. And the last one there in blue would be negative 4 and negative 7. This question actually has exactly every single example of your rules for integers. It has 2 negatives, 2 positives, and what do you do when the signs are different. In blue, they're both negative 4 and negative 7. So therefore, in this question, you are keeping the negative and add up your 4 and your 7, so negative 11x, because you're going more and more in debt. So negative 4, then another negative 7, so you owe you owe a negative 11. This cannot go any smaller. This is your final answer. Next question. Careful, I always have to get rid of brackets first. So you have a little thing here you have to worry about in front, the negative, and then this you just rewrite. So x becomes minus x, because really it's like a little plus in there. Minus 5 becomes positive 5y. So step 1, I got rid of the brackets. This is all done. All done. Just rewrite everything else nice and neat. You're not finished. That was step 1. Step 2, you are now doing like terms. That was just the bracket issue. Now you want to put all your same variables together to simplify it. So these together, negative 1 and a negative 7. So I have negative 8x. And then your next one, you have a positive 5 and a minus 2y. 5 minus 2, just simply plus 3y. Remember, that is your final answer right there, negative 8x plus 3y. Now, when it comes to fractions, I would strongly suggest that you actually work the fractions out. I know some students will change to decimals, so I will show you both methods. Keeping fractions, I would suggest that you actually rewrite the same variable beside each other. And let's worry about the y's after. Plus 3 over 10y. So all I did was I put my x's together, and then I put my y's together beside each other. So if I just worry about this one here, the x's only first, okay? Only the x's first. Remember last year, fractions, common denominator times 4 on the bottom. I have to say times 4 on top. 12, how do I go from 4 to 12? Is times 3 on the bottom. So therefore I must do the same thing times 3 on top, right? So I'm going to go put that back in the same color. So I have 9x, kind of the same color. I'm going to do the same thing for my y's. This time be careful, I do have a minus here, negative, and easy, right? Common denominator would be 10 times 2 on top. The 10 doesn't change. Then I can put them together. So my x's, 8 plus 9 is 17 over 12x. Then I have, be careful, I have a minus and a positive, minus and positive, negative, negative, positive kind of thing. I'm subtracting, so take 3 out of the 8, 5 over 10, y, and my 8 is bigger, so it tells me what's left over, negative. Now I do want to simplify that though. You can change those to decimals as the final answer. If you keep it as a fraction, okay, remember how you go 12 into 17, mixed to proper fraction. Sorry, improper to a mixed fraction. So 12 goes in there once, 5 left over 12x, keeping in fractions, and here I can reduce that to a half a y. That's your final answer in fractions. If I do the same question using decimals, change everything to decimals. So 2 divided by 3, and always round properly, decimal 67x minus 0.8y, positive 0.75x, and 0.3y. The math is no different. It's just messy, right? My decimals, my x's, my y's, it's all the same. So if you do have little tricks for yourself, use it. I'm going to use my highlighter here. So I'm saying positive 67, like 67 cents, plus 75 cents. That's just simply, if I add those two together, right? 67 plus 75. So if I find my calculator here, so decimal 67 plus decimal 75, it's simply just saying $1.42. So 1.42x in blue here is done. Then be careful, I have a negative decimal 8 and a positive decimal 3. It is a y. Take decimal 3 out of decimal 5. So 30 cents out of 80 cents, I'm left with 50 cents. And decimal 8 is bigger, so it is a negative that's left over. Lots of practice. Now these two answers are exactly the same thing. Decimal 5 is definitely the same, right? Negative half is the same thing as negative 0.5. Also, if you divide 5 over 12, the 1 is exactly the same. The 5 over 12 is exactly decimal 42 rounded. So it's the exact same answer.